In this video, I'll explain how to find polar form of a complex number. Consider any point in plane, then that point is located using Cartesian coordinates. Cartesian coordinate system has two axes, x-axis, y-axis, and their meeting point is called as origin, which is represented as 0, 0. So any point in plane is represented using ordered pair of numbers x, y, where x corresponds to the length along the x-axis and y corresponds to the length along the y-axis. This is how we plot or we locate a point in plane. Now we know that every point in plane can be associated with the complex number. See, for example, any point in plane x, y can be associated with its complex number x plus iy. So, this plane is full of complex numbers. 0 can be associated with the complex number 0 plus I into 0. That means there is a one-to-one correspondence between the points in a plane and the set of all complex numbers. Hence, when this plane becomes full of complex numbers, we call that plane as argand plane or complex plane. So, in argand plane, each point is represented as a complex number x plus iy, and x axis becomes real axis and y axis is called as imaginary axis. Now, there is one more way to represent a point in plane, that is using polar coordinates. In the case of polar coordinates, there is a pole which is a fixed point, and this initial line, distance of the given point from this pole, which is called as a radius r, radius vector, where theta is the angle made by this radius vector with the initial line, and this theta is measured in the anticlockwise direction. Therefore, when you change the point, then r as well as theta changes. So, any point in plane can also be represented using polar coordinates r, theta. Now, the polar form of any complex number is given by z equal to r into cos theta plus I into sin theta, where r is the modulus of the given complex number, which is square root of x square plus y square, and theta is the argument of z. Argument of z, if it is restricted to minus pi to plus pi, that is open interval minus pi to closed interval pi, then such theta is called as principal argument of z. So here in the polar form, we are always finding the principal argument of the given complex number. So to find the principal argument, we need this acute angle alpha, which is calculated as tan inverse of modulus of y by x. We know that for every point there is unique complex number associated with it. Therefore, if the given complex number's corresponding point is on the positive x-axis, for that principal argument equal to 0. On the positive y-axis, principal argument equal to pi by 2 or 90 degree. On the negative x-axis, theta equal to pi, and on the negative y-axis theta equal to minus pi by 2. That means for the first two quadrants go in the anti-clockwise direction, then for the remaining two quadrants go in the clockwise direction. So let us see, when a point lies in quadrants, how to find the principal argument. See here, if the point is in the first quadrant, then theta equal to alpha. Alpha means tan inverse of modulus of y by x. If P is in the second quadrant, theta equal to pi minus alpha. If the point is in the third quadrant, theta equal to minus pi plus alpha. If the point is in the fourth quadrant, then theta equal to minus alpha. Point means whenever a complex number is given, you have to write its corresponding point, and hence you have to find out where that point lies. This is the basic rule. Let us find out polar form of some of the complex numbers. Find the polar form of 10. Okay, the polar form of any complex number is given by z equal to r into cos theta plus I into sin theta. So I need r, modulus of z, and I need theta, principal argument. So here 10 is purely real number, and this corresponding point associated with this complex number is 10 comma 0, because 10 plus I into 0, 10 comma 0. 10 comma 0 lies on the positive x axis. Therefore R value is its magnitude 10 itself, because square root of x square plus y square, even if you do, you will get the same value, because x is 10 and y is 0. And theta is equal to, here it is on the positive x axis, means principal argument is always equal to 0. Therefore, for this first problem, its polar form is given by z equal to 10 into cos 0 plus I into sin 0. Now see the second question. It is 100i. This is purely imaginary number. X value is 0, y value is 100. It is on the positive y axis here. The point is 0, 100, which is on the positive y axis. So for a point on the positive y axis, theta equal to pi by 2, and the value of r is equal to 100, the value of this magnitude itself. Hence its polar form is z equal to 100 into cos of pi by 2 plus I into sine of pi by 2. Now see the third question, minus 50. This is purely real number and it is on the negative x axis. Therefore, theta equal to pi. For a negative x axis, theta equal to 180 degree, and r is equal to 50, because magnitude is always positive. Hence, its polar form is z equal to 50 into cos pi plus I into sin pi. Next, fourth one, last one, minus 20i is on the negative y-axis, because the corresponding point is 0, minus 20. So, r value is 20, because the modulus is always positive, and theta is equal to, argument is equal to pi by 2 with a negative sign, that is minus pi by 2, because it is on the negative y-axis. Therefore, the polar form of this complex number is 20 into cos of minus pi by 2 plus I into sine of minus pi by 2. So this is how we find the polar form of the complex numbers whose corresponding points are on the axis. Now find the polar form of these complex numbers. So first you have to write the points associated with these complex numbers. Here 1 comma 1, and here root 3 comma minus 1, here 1 comma minus root 3, and here minus 1 comma minus 1. Now this first question 1 comma 1, this is in the first quadrant. So for first quadrant, we have to get the value of r. R is square root of x square plus y square, which is equal to root 2, because 1 square plus 1 square gives you square root of 2 here. And theta is equal to alpha, because the point is in the first quadrant. Alpha is calculated as tan inverse of modulus of y by x. So alpha equal to tan inverse of y is also 1, x is also 1, that is 1. So alpha equal to pi by 4, 45 degree. Therefore, theta is also same as this alpha, pi by 4. Hence its polar form is r is root 2 into cos pi by 4 plus I into sin pi by 4. Now for this second problem, first let us find out r. Square root of root 3 whole square is 3 plus minus 1 whole square is 1, so which is equal to 2. Square root of 4, that is nothing but 2. So to find theta now, theta is equal to this point, x is positive, y is negative, that is in the fourth quadrant here. In the fourth quadrant, theta equal to minus alpha. Now we need alpha first. Alpha is tan inverse of modulus of y by x, which is equal to tan inverse of modulus of y is minus 1 by x is root 3. Therefore, tan inverse of 1 by root 3 is 30 degree it is, so it is pi by 6. Hence its polar form is z equal to 2 into cos pi by 6 plus I into sin pi by 6. Now similarly, take up this third problem. So here I'll change this sign, minus 1 plus root 3, because one problem point in the fourth quadrant is already over. So here x is minus 1 and y is root 3 now. So x is negative, y is positive, means it is in the second quadrant. So second quadrant, theta equal to, so I will write here, theta equal to pi minus alpha. So alpha I have to find out, tan inverse of modulus of y by x, which is tan inverse of y is root 3 divided by minus 1, which gives you tan inverse of root 3, positive only because there is modulus, so it is for 60 degrees, so pi by 3. Hence, theta equal to pi minus pi by 3, which gives you 2 pi by 3. This is the principal argument. Therefore, polar form z equal to r, you have to find out. R is calculated as square root of minus 1 whole square is 1, root 3 whole square is 3, which is nothing but 2. So it is 2 into cos 2 pi by 3 plus I into sine 2 pi by 3. This is for the third problem. Now for the fourth problem, it is minus 1 minus I. The corresponding point is minus 1 comma minus 1. Both are negative. So it is in the third quadrant. In the third quadrant, theta equal to minus pi plus alpha. So let us find out alpha first. Tan inverse of modulus of y by x, which is minus 1 by minus 1 plus 1. So tan inverse of 1 is nothing but gives you pi by 4, 45 degree. Hence, theta equal to minus pi plus pi by 4, which is equal to minus 4 pi plus pi minus 3 pi by 4. Therefore, theta is minus 3 pi by 4 and r value is square root of minus 1 whole square 1 plus 1, which is root 2. Hence, polar form is r is root 2 into cos of minus 3 pi by 4 plus I into sine of minus 3 pi by 4. So this is how we convert the given complex number into the polar form. I hope you understood the concept. Thank you for watching.